Welcome back everyone to another video. Consider the following species: carbon tetrafluoride, methylium, and borane. Identify those with bond angles of number 1, 120 degrees, number 2, 109.5 degrees. First of all, what we want to recall in this problem is that the steric number allows us to identify bond angles very easily. 120 degrees, that would correspond to trigonal planar geometry. That's what we have to recall from the VSEPR theory. And this bond angle ideally corresponds to a structure with a steric number of 3, meaning we are going to look for 3 electron regions around the central atom. Now, the second bond angle corresponds to the tetrahedral geometry. And the steric number ideally would be 4. We're looking for 4 electron regions around the central atom. First of all, we're given carbon tetrafluoride, so carbon is the central atom. And we're going to bond 4 fluorine atoms. Okay, so that would be our structure. Of course, there's no necessity to add those lone pairs around each fluorine, but what we notice is that the steric number in this case is 4 because we have 4 individual electron regions, in particular 4 carbon-fluorine bonds. This gives us a steric number of 4, and we know that a steric number of 4 corresponds to tetrahedral geometry, so that means we would expect bond angles of 109.5 degrees. The next structure is methylium, CH₃ with a positive charge. We can simply draw methane to begin with. We know that methane has 4 carbon-hydrogen bonds. And if we get our carbocation, it essentially means that the electrons are taken away by hydrogen. So we simply lose that carbon-hydrogen bond, right? And we end up with CH₃ with a positive charge on carbon. Okay, we don't have any lone pairs, so once again the steric number is just the sum of individual bonds. We have 3 carbon-hydrogen single bonds, so the steric number is 3, and therefore if the steric number is 3, the expected bond angle would be 120 degrees. Trigonal planar geometry. Borane. Well, we have to remember that borane is an exception to the octet rule, and boron specifically has 3 bonds, and it would have no charge when it only contains 6 valence electrons around it, similarly to aluminum. So the structure of borane would essentially consist of 3 boron-hydrogen bonds. Okay? What do we notice? The steric number is once again 3 because we have 3 electron regions, and therefore the bond angle would be 120 degrees. Trigonal planar geometry, right? So we can conclude our answers. For 120 degrees, we would expect to observe 2 structures. One of them would be methylium, and the other one would be borane. Number 2. For 109.5 degrees, we would observe carbon tetrafluoride, tetrahedral geometry. That would be it. Those would be our final answers, and thank you for watching.